Sum and difference trig identities. We've dealt with this before. We've done things like sine of 60 degrees or cosine of 225 degrees. Cosine is the x value, sine is the y value. But when I see something that looks like this problem in the middle, sine of 105 degrees, the thing that troubles me is that this isn't one of those things that I've memorized for my unit circle. So we're going to end up writing it as two numbers that are on my unit circle. So we're going to write the sine of 105 as sine of two things that are on my unit circle that will add or subtract to give me 105. Easy one. 60 plus 45. Both of those are on my unit circle. I know what the sine of 60, I know what the cosine of 60, sine, cosine of 45. I know what all that is. So we're going to use that here in a second. So just as a little practice, what are some other things that we could use for 105? Maybe I said 60 and 45 and you had something else in mind. So on this next slide, I've got ways for you to practice just coming up. You may want to push pause, rewrite some ways where you can add or subtract to give you 105. So we had, 60 and 45 to start with? You could also do, I don't know, sine of 150 minus 45? You could do sine of 135 minus 30? And sine of 225 minus 120? I think all those are right. Those all give you 105. So any of those would work. We're going to show you what we need to do with that later on, but that's first step. Got to write down two things that add or subtract to give you the 105. Next is knowing these formulas. So these are blanks in your notes. You need to copy these down. These are the formulas we're going to use here in a second. You're going to need to have these memorized. So when I look at this sine of 105, and we wrote sine of 60 plus 45 to start with. Okay. And I'm going to go back to this slide. And I'm saying, well, I wrote 60 plus 45 up here. That means I'm going to be using this right here. And this was my 60, and this was my 45. So I'm just going to plug that into the formula. Okay. So that would be equal to, the first thing that I come up with, I always say the sine function goes sine, cosine, sine, cosine. And sine is always the same sign. Cosine will be opposite sides, but sine is the same sign. And sine of 60, cosine of 45. And this time we're going to do the sine of 45 and the cosine of 60. And we know what the sine of 60 is. It's in that first quadrant. Sine of 60 is square root of 3 over 2. Cosine of 45 is square root of 2 over 2. Sine of 45 is square root of 2 over 2. And cosine of 60, that's the x value, that's 1/2. We're going to multiply these together, get square root of 6 over 4 plus square root of 2 over 4. And we're going to write that all over one fraction. Now, if you had written, so there's your answer. If you had chosen something other than 60 plus 45 in the beginning, you would get the same exact answer. You may end up with a different, step here. It'll look different here, in which case these might be in a different order, but this final answer is going to be the same thing. Okay. Next, sine of 255. So I have to come up with two things that will add or subtract to give me 255. Right off the bat, I'm thinking 210 and 45. 210 and 45. So let's do 210. plus 45. So 210's over there, in the third quadrant, down past 180. So, all right, sine will be sine, cosine, and sine is the same sign. And it'll be sine of 210, cosine of 45, sine of 45, cosine of 210. So sine is the y value. Over there on the left, down past 180, I believe it's negative 1/2. Negative 1/2. And cosine of 45, we've done that one. That one is square root of 2 over 2. Same with the sine. And the cosine of 210 would be the x value. That's negative square root of 3 over 2. So when you multiply them, negative square root of 2 over 4 plus, I should put in minus, negative square root of 6 over 4. So that's negative square root of 2 minus square root of 6 over 4. So the question I usually get right now is that not like really similar to the thing we got as our last answer? Yes, it is. All of these, you're going to get something very similar to that. All these signs in front of the square root of 2 and square root of 6, that's the only thing that's going to really change for you. So there's really only 4 options on these, at least, that I'm going to give you, okay? All right, let's look at the next one. I got cosine of 75. Now, if I was, easy one would be to add and get, what, 30 plus 45? Can I do a subtraction one? Could I do maybe like 225 minus 150? Just to spice things up a little bit. 225 minus 150. So I could have done 30 and 45. That would have been a perfectly easy way to go about this. It's probably the easiest way. If I have to subtract, I want to at least show you one way to subtract. So a cosine function. A cosine one goes cosine, cosine, and then it's the opposite sign, sine, sine. So this is 225, 150, 150, 225. All right, cosine 225, that's over there down past 180. That's one of those 45-degree ones. So that's going to be negative square root of 2 over 2. And that means that this one's going to be negative square root of 2 over 2. 150 is right there before you get to 180. So cosine is going to be square root of 3 over 2. And one sine is 1/2. So that's negative square root of 6 over 4. I'm going to write the plus minus again. Square root of 2 over 4, which is negative square root of 6 minus square root of 2 over 4. All right, that's nice and easy. Let's crank it up a notch. Let's deal with some radians here. All right, we've got same thing, dealing with radians now. And the weird thing about radians is that I don't want to say all the time, but stuff that I'm going to at least show you right now in the video is the denominator is going to have 12 in it as opposed to other things, and you're going to have to find a common denominator. Okay, so what I would do is I would start and make a little list, and I'd say pi over 12 and 2 pi over 12 and 3 pi over 12 and 4 pi over 12, and I'd keep writing all the way down until writing until I got all the way down to maybe 12 pi over 12. You could go all the way to 24 pi over 12. That'd be 2 pi. But then I'd go through and I'd see which ones could reduce to things on the unit circle. So pi over 12, that's as far reduced as it'll go. 2 pi over 12 can be rewritten as pi over 6. That's on my unit circle. That's going to be helpful for me. I'm going to use 2 pi over 12 at some point. 3 pi over 12, that's pi over 4 when it reduces. I'm going to use 3 pi over 12 at some point because it will reduce to something on my unit circle. It says 4 pi over 12. That's pi over 3. That reduces to something on my unit circle, so I'm going to use that at some point. Now I would go through and I'd write it up 5 pi over 12, 6 pi over 12, 7 pi over 12, 8 pi over 12, 9 pi over 12, 10 pi over 12, 11 pi over 12, and 12 pi over 12. I'd write all those down, simplify them so that it'll help you out here in just a second, okay? All right, so it says when you get asked to find cosine of 7 pi over 12, that's not on your unit circle, you need to realize that 7 pi over 12 is the same as 3 pi over 12 and 4 pi over 12, which we know those are on our unit circle. Okay, then we'll just use our formula that we had in the very beginning. So, and it says cosine of 7 pi over 12. We got that by saying cosine of 3 pi over 12 plus 4 pi over 12. We found two things on our little list that would add to give us 7 pi over 12. It was important that those two things were things that would reduce to something on our unit circle. We didn't choose 5 pi over 12 and 2 pi over 12 because 5 pi over 12 isn't on my unit circle. It doesn't reduce down to something. Okay. Could have done 10 pi over 12 minus 3 pi over 12 because 10 pi over 12 is 5 pi over 6 and 3 pi over 12 is pi over 4. So both of those have been on unit circle. So anyways, we chose cosine 3 pi over 12 plus 4 pi over 12. That reduces to pi over 4 and pi over 3. And now we're just going to use our formulas. So I got cosine goes cosine, cosine, and then it's the opposite sign, sine, sine, and it's pi over 4, pi over 3, pi over 4, and pi over 3. Cosine of pi over 4, that's in the first quadrant. It's nice and easy. That's the square root of 2 over 2. Cosine of pi over 3 is right next to that, and the x value is 1/2. That's square root of 2 over 2, and then this would be square root of 3 over 2. Sine is the y value. Let's multiply. Square root of 2 over 4 minus square root of 6 over 4, that is square root of 2 minus square root of 6 over 4. There's those same numbers again showing up. So let's look at this one. I got a sine function, 5 pi over 12. So I need two things on my unit circle that will add or subtract to give me 5 pi over 12. So I'm looking at my list, the pi over 12, the 2 pi over 12, 3 pi over 12, and I'm looking at things that will reduce to something on my unit circle. First one that comes to mind is 2 pi over 12 plus 3 pi over 12. Like that seems to be the first one to come to mind. Okay, 2 pi over 12 plus 3 pi over 12. And I know that I can use those because they reduce down to pi over 6, which is on my unit circle, and pi over 4, which is on my unit circle. Then I'm just going to take the formulas. I got sine, cosine. Sine is the same sign. Sine, cosine. So this is pi over 6, pi over 4, pi over 4, pi over 6. And pi over 6 is that very first one over there on the right side. The sine is the y value. That would be 1/2. That would make this over here square root of 3 over 2. And then pi over 4 is the square root of 2 over 2. So final answer is going to be square root of 2 plus square root of 6 over 4. Let's look at maybe one more of these, and then we'll try some more. This is a good one. Sine of pi over 12. I have to subtract on this. Like, there has to be a negative somewhere on there. So I'm going to just say sine of two things that are on my unit circle. You could do 4 pi over 12 minus 3 pi over 12. You could do 10 pi over 12 minus 9 pi over 12. or 9 pi over 12 minus 8 pi over 12. All those are on your unit circle. I'm just going to use, let's do 4 pi over 12 minus 3 pi over 12. So that's the same as sine of pi over 3 minus pi over 4. And it's just my sine function. That's a sine, cosine. Sine is the same sign. So this is pi over 3, pi over 4, pi over 4, pi over 3. And sine of pi over 3, that's the one. Sine is the y value, so that's square root of 3 over 2. That makes that 1/2. This is square root of 2 over 2, square root of 2 over 2. So that's square root of 6 minus square root of 2 over 4. Another common question that I get is, do the square root of 6 and square root of 2, like, is it okay if I wrote negative square root of 2 plus square root of 6 over 4? Yes, that's perfectly fine. Perfectly fine. All right. Let's scroll down a little bit. Let's find some of this. There we go. All right. If I see something like this, is kind of working backwards. So sine of 5 pi over 12, cosine pi over 12, and then vice versa on the other side. None of this is on my unit circle. If it was like sine of 4 pi over 12, cosine 3 pi over 12, I would change it to cosine or sine of pi over 3 and cosine of pi over 4, and I would just kind of punch it in right there. But it doesn't say that. 5 pi over 12 is not on my unit circle. Neither is pi over 12. I know that it's a sine function because it goes sine, cosine, sine, cosine. So it's a sine function. Sine has the same sign. So I can rewrite this like this. And then I can combine like terms inside in there. That's 6 pi over 12. 6 pi over 12 will reduce to pi over 2. And the sine of pi over 2 is equal to 1. Next, 3 pi over 12 is on my unit circle here. 7 pi over 12 is not. 3 pi over 12 will reduce to pi over 4. But if both of them don't reduce, that's not really helping me too much. Okay, so this is a sine function. Sine is the same sign. 7 pi over 12, 3 pi over 12. That makes that sine of, what, 4 pi over 12? Which is sine of pi over 3. Pi over 3, the y value of that is square root of 3 over 2. Let's do one more of these. All right, I got a cosine function. So cosine of 11 pi over 12. Cosine is the difference sign. 7 pi over 12. So this is cosine of 4 pi over 12. Cosine of pi over 3. The x value of that is equal to 1/2. All right. Last style here. We got some proofs. So let's look at this one. Sine of x plus pi equals negative sine. So we got to prove this thing. We're going to take that stuff on the left side. It's an addition, a sum identity. And we're just going to take the rules and apply it. And hopefully it ends up with negative sine of x. So this stuff on the left side, it's an addition. It's a sine. So this would be sine, cosine, same sign, sine, cosine. This would be sine of x, cosine of pi, sine of pi, cosine of x. So sine of x, can't change that any. Cosine of pi, so cosine is the x value of pi on the left side, is -1. And sine of pi is 0, and this should be cosine of x over here. Well, that's going to be 0 right there, isn't it? So all I'm left with is stuff on the left side, which would be negative sine of x. Got it. Let's look at another proof. Cotangent of pi over 2 minus x. So cotangent, we weren't given a formula for cotangent. Why is he giving this to us? Well, how can I rewrite cotangent? I know cotangent is cosine over sine, right? So this is the same as saying cosine of pi over 2 minus x over sine of pi over 2 minus x. Then I can do the formulas up top and on the bottom. So cosine goes cosine, cosine, opposite signs, sine, sine, and that would be pi over 2x, pi over 2x. Sine goes sine, cosine, same sign, sine, cosine, and then it's sine of pi over 2 cosine of x, sine of x cosine of pi over 2. Hope that's right. We'll find out. All right, so pi over 2, the cosine of pi over 2, right here, that's 0, I think, times cosine of x, plus the sine of pi over 2 right here. The sine of pi over 2 is 1, that's the y value, times sine of x. On the bottom, we just said sine of pi over 2 is 1 times cosine of x, plus that is 0. So things that will cancel out for us, that's 0. That's 0. So that just means that I'm left with sine over cosine, which is tangent of x. One more. You've made it 22 minutes. One more. Cosecant. So very similar to the last one. This one would be 1 over sine of pi over 2 minus x. So we're going to have 1, and then sine goes sine, cosine, same sign, sine, cosine. That's pi over 2, x, x, pi over 2. And, okay, so that's 1 still up there. Sine of pi over 2 is the y value. So y value is 1. Cosine of x minus sine of x times 0. That's the x value of pi over 2. So that means all that's 0. That means I'm left with 1 over cosine of x, which is secant of x. You made it. Congratulations.